Hi everyone, thank you for attending my session. Today I'm going to talk about advanced cyber defense techniques for AI-driven threat vectors. My name is Nyan. I'm the CTO and CISO of a Singapore-based cybersecurity company called Athena Dynamics. So before I start, just a little bit of my background. I started as a PHP and C# programmer, and I did system deployments and I did a lot of supports for various critical infrastructure projects, including public sector, defense, water plants, power plants, and maritime vessels most recently. And the company that I'm working for, Athena Dynamics, is part of an SGX mainboard listed maritime group called BH Global. So you can see my journey. I started as a developer, changed to cybersecurity consultant, become implementation support engineers, doing pre-sales, business development, and now I'm taking the portfolio of CISO and CTO. So to start with, I think everybody is very familiar with all these logos here. We started with ChatGPT. It caused a whole new era of all the AI agents and LLMs. So all these LLMs started from the text-based capabilities, right? So we go to the LLM, we type whatever queries that we have, we get a very realistic response. So from ChatGPT, Gemini, DeepSeek, Cloud, it gets more and more expanded, right? So from there, we get image generation capabilities. So Google has Nano Banana, and there are a lot of other image models as well that can actually create images that are very, very realistic. And from there, we actually move on to the video generation capabilities. I think you have probably seen videos generated by AI using VO3 from Google. These days, there's CDance 2.0, which can generate really realistic videos and almost a short movie. Some people are creating short movies with that, and it's very realistic. And they're clean AI and all this as well. So it becomes more video generated as well. And the latest trend, I think a lot of people have seen it. It's called agentic AI, right? So instead of just asking the AI for information, what we're doing now is we're getting the AI to do stuff for us. So it becomes our arms and legs. So I think a lot of people saw the news about CloudBot, which eventually was branded to OpenClaw, and they are working very closely with OpenAI, if I'm not wrong. And this gets very, very popular, and because it's mainly because it's very easy to set up and it can do a lot of stuff for you, like your personal assistant. So with all these advancements, we can see what kind of issues it brings about. So for the text-based capabilities like ChatGPT, we can see that it causes advanced spear phishing at scale, because the scammers don't really need to write the phishing emails manually. They can just generate it and they can write it very realistic and make it very properly formatted with the correct grammar. So it's getting harder to do the harder to detect the spear phishing attacks. And because of this, it's also enabling because of the coding agents, right? A lot of people are doing vibe coding, and that also means that malware scripting is now being vibe coded as well. So previously, for a malware actor to actually know how to write a script, they need to have the programming know-how. They need to know how to actually write certain malware to touch on certain system components. But now everything can be auto-generated by the AI. So it's getting easier for the script kiddies to actually create more damaging malwares. And that also means that there are more mechanisms that allows bypassing of the existing detection tools like antiviruses or sandboxes via new AI-generated malware variants. On the image side, we can see that there has been a lot of AI-generated deepfake pictures for scamming purposes, because the pictures are getting so real, and the scammers don't really even need Photoshop or anything to actually try to fake something. They can generate very, very photorealistic pictures just with AI. So that actually caused a lot of scams, investment scams, and all this. And I think recently in the news in Singapore, there was even a case where a scammer was pretending to be Elon Musk and scam one of the elderly women in Singapore out of about, I think, $600,000. So these kind of scams are getting very, very common, and stealing of intellectual property, of course, because the image generators, they're just amalgamating all the different information that is available online, which includes all these IP, like different cartoon characters, different characters that has IP owned by someone else, and they're not allowing people to use it. But because of all these LLMs, they're just combining everything and stealing all this IP. On the video generation side, it's similar, but it's worse, right? Because previously people rely on the videos because image can be photoshopped, so video is not so easy. So a lot of people rely on video as evidence. But these days, with the deepfake videos and a lot of AI generated videos, the scamming is getting more and more realistic, and it's getting harder to actually differentiate the real from the fake one. And there are a lot of face filters that actually fools people as well, right? So for example, this YouTuber actually used one of the filters. He's a guy, and he tried to pretend as a woman, and he can do all sorts of things real time, right? And the filter will actually make it seem like it's a real girl talking. And imagine there has been scenarios where the scammers try to pretend to be a CFO, and even go on a Zoom call to allow the people to verify before actually scamming millions of dollars. But all this, in my opinion, the biggest threat so far is on the agentic side, because the agents are doing all sorts of things for the human. They are the arms and the legs, right? So they are actually doing all sorts of things. This is a screenshot taken from the OpenClaw website. It can do a lot of things, out of which these two are the most concerning, which is the browser control and the full system access. So basically, it can use the browser like how a normal user would, and it can actually have the full system access as admin, because the agent needs to do stuff for the human, right? So it needs an admin right to be able to execute a lot of things. This also means that the potential for being abused is very, very high, because the AI agents, actually, they are still in relatively nascent stage, right? So most of these are not really built with security in mind. Of course, there are a lot of security guardrails available right now, but there's always going to be something that the hackers can use to take over these systems and actually get a full access, unrestricted access to the whole system and all the personal data of everything. So this is quite a scary thing if proper guardrails are not very implemented very properly. And there's also the mode book, right? So I think a lot of us see this as well. And be it real or fake, there has been comments that some of these are actually fake posts by human, and not everybody on the mode book is a bot. But either way, one of the posts actually posted a human's Ethereum private key, just because the bot is not very happy with the human. So these kind of things can happen because they have access to all the private keys, all the password managers and everything, because it needs to access all different systems, right? So this can actually pose a lot of damaging things if the bot is not really controlled properly. And some of the security researchers actually managed to compromise the database behind Mobbook and able to get all the secret API keys, including some of the famous people with a lot of influencers, right? So imagine people personating as famous influencers in a specific space and try to get people to buy into, let's say, like scammy crypto coins or whatever kind of scams that they're up to, right? So that's quite damaging on the social engineering front as well. So the things that can be done in order to get protected more from the infrastructure perspective, right? So there are a lot of attacks that can happen to the infrastructure. So Things like MCPs, RAG, agentic AI implementations, they are more contextual in nature. So basically, it's just to give more context to the LLM so that it can actually answer and do things more in the relevant context instead of a generic kind of reply. And there are a lot of prompt injections available on the cloud. There's man-in-the-middle attacks. It can also expose some of the sensitive data. There's also it's basically an additional external facing attack interface. Right? So on premise, that's the toughest things to get protected. Because when you are designing such a sophisticated secure air-gapped infrastructure, just because the context that you need to provide is in a sensitive area, so you don't really want to expose it to the LLM. So designing such an infrastructure is actually expensive and tricky because there are a lot of layers to do. There are a lot of redundancies that needs to be taken care of and stuff like that. So it's all about features versus security, right? Because if you want to do the least privilege principle or zero trust, the strictest security, the LLM might not work properly, and you might not get some of the information that you need, and probably in some cases it kind of defeats the whole purpose of having this LLM in the first place because it cannot get the required data. So today's focus, I would talk mainly on how to protect these two, more on the text-based kind of capabilities, the threats rising from these kind of text-based capabilities, right? How to get protected, as well as the agentic AI side, from protection of the infrastructure perspective. So for text-based capabilities, there's advanced spear phishing at scale is possible, just to help you recall, and these are all the issues. Similarly, for the infrastructure perspective, the implementations need to be properly secure. So first, for the text-based side, the overview of the traditional security defense, right, is based on the detection-based mechanisms. So it's actually based on what you know. So the things like antivirus, endpoint protection, EDR, UEBA, sandboxes, all these are based on detection mechanisms. Because what they're doing is they're trying to identify what is a known threat, and they try to compare it against a file that they come across, and they try to compare it whether this is potentially a known virus or a known infection. But the common fallacies is that the threat actors are also human, right? So they are also always trying to find continuously to avoid detection. So just because you didn't detect anything doesn't mean that it's safe, because attackers can always try to bypass the detection mechanisms. So the traditional security detection mechanism, to give you an example, let's say you are in a meeting room. How would you know that the table that you're sitting on has any bacteria or viruses sitting on them? So the traditional approach is just trying to use maybe a microscope to actually try to find, if there's any virus, and if there's one, remove it. But this approach is not really efficient because there are a lot of microscopic bacteria that can exist on the table interface, and you can't really detect everything and remove. There's always be something that you missed out. Right, so you remove two, you might miss one. So there's a more foolproof kind of approach that is being used in the military, government sectors, and all the advanced infrastructure, which is called content disarm and reconstruction. So this is a file protection kind of mechanism. So what it does is just now the same interface, same scenario. Instead of trying to use the microscope to find, just use a sanitizer to spray. So what you did is you just spray the whole interface of the table. You don't really care whether there was any virus or not, but what you are pretty sure is that after you spray the sanitizer, the table is clean. So that's the main essence of non-detection based technologies, right? So this is mainly used for file sanitization, and it's non-detection based. It treats every single file as potentially infected file. So it just cleans everything based on a set of algorithms. Maybe the file originally might be clean, or might be dirty, might be infected, but after cleansing, we are pretty sure that every file is clean. So it just cleans it based on a set of algorithms, depending on the file type. There are many ways to do it. So it's getting more important because file-based attacks account for more than 75% of the incidents, and there's a lot of hidden weaponized contents, and especially with the AI, there are a lot of ways that hackers are making use in order to hide what is inside the contents, the malwares. And over 90% of all these malicious attacks are delivered through daily operation channels. So things like email, web downloads, file shares, USB devices. So all these are very common entry points that actually need to be protected. So the main pain points being addressed here are that the file sent or received via email, USB, internet, all these, there's no way to ensure that it's safe. And because advanced threats are not detectable by traditional detection-based mechanisms, so zero-day attacks, encrypted malwares, so you have a virus and you just encrypt it with a password, a lot of the detection mechanisms will not be able to detect because it's encrypted. And there will always be new variants of the existing malwares. So it's not an antivirus, but it still uses antivirus as next-gen AVs, just as a pre-filter. So what it does is it just try to clean out all the known viruses, and those missed out by the AVs or not detected by the AVs, then are actually cleansed using CDR. So it actually saves a lot of bandwidth. It prevents sophisticated file-based attacks. It disarms the file, transforming them into the neutralized copy, while doing so, maintaining the usability and functionality of the file. This is the most important because it kind of defeats the purpose if after you cleanse the file is not usable at all, right? So it's very important to keep it as similar to the original as possible while effectively removing the malware. On the second part, on the agented AI side, I'll talk more about the infrastructure perspective. How do we actually protect? So there are a couple of different ways that you can deploy the LLM, right? So the cloud LLM deployment is the most simple. So it's basically the cloud version that you have on ChatGPT, Gemini, and so on. It's very simple, straightforward API calls. Maybe you want to use it from one of the applications that you have. The application will call the API of the LLM, and just based on the tokens, it would use up whatever is needed. Standard web-based kind of usage as well, right? So there's no powerful hardware or GPU servers needed. You don't really need to maintain anything. But that also means that you also don't have much control over the data sent or received because it actually resides in a cloud provider's servers. So you don't really have much control over it. So it's actually suitable for non-sensitive data, right? So just asking how to do certain things, you do some online research on the publicly available data, brainstorming some ideas, etc. Nothing for the sensitive. But the problem is employees are sending a lot of sensitive data from the corporate to the cloud LLMs because they are very used to using it for their daily operations that sometimes when they're doing the work, they just know that, if I just throw this question to LLM, I would just get an answer very quick. Or maybe this is a 1 hour job, but if I throw it into LLM, I can get it done in 10 minutes. So there's this natural tendency to send all these things, even though they might or might not know that this is sensitive data from the corporate. So, and because there's not clear guidelines or assurances from the corporate side, a lot of them don't really have a policy or rule prohibiting employees from doing certain things because LLMs are so new, right? So there's no way to have clear assurance from the cloud provider after the data is being sent to them. There's also potential vulnerabilities residing on LLM providers' servers, right? So while doing prompt injections, it can review other users' data or can perform privilege escalations. The attackers can do remote code execution on the LLM provider server if it's not secured properly. It's beyond our control as users. So this is something that we need to be mindful of. There's also connections to the sensitive corporate SaaS platforms via MCPs because MCPs are getting useful. It links to all the different platforms like your Salesforce, your SAP, and all these. So we need to be more careful about the sensitive data being sent, right? So how to protect? This is just basically the policy-based kind of solution because you have to have strict organizational AI usage policies. The staff need to know what is possible, what is not, what is good, what is bad, and they need to fine-tune the existing security tools to adapt to LLM use cases as well. So, for example, they might have the DLP tools, but it might not be covering the LLM use cases. So it can actually extend to detect the usage of LLMs, enforce appropriate controls. You can also design more proper and secure cloud architecture when interfacing with cloud LLMs. So if you have a cloud application that has a lot of your organization's sensitive data that is talking to a cloud LLM, you need to make sure that the connections are being scrutinized to actually know, like, basically it's just only sending whatever is required, and there's no way for the attackers to lateral into your systems and get the data. So when it comes to on-premise and hybrid, it gets more complicated because it requires, as a basic setup, even without taking security into considerations, it requires somewhat powerful service for you to run. And although you don't really need to train it, so you don't really need very, very high-end servers, but still relatively higher kind of specs, because the models, especially the more detailed and the bigger ones, are pretty huge. So you need more powerful servers. Although now these days, there are models with much smaller parameters that can actually even deploy on a personal PC. Those have limited use cases and limited power as well, right? So if you're really using it for the enterprise use cases, you need a more powerful server and more powerful setup. You have full control over the data sent or received, as long as you can make sure that there's nothing that can go out to the internet, not even accidentally. Because when you do this kind of on-premise setup, sometimes people do it hybrid, meaning a little bit of on-premise and a little bit of cloud. So in this case, you need to really make sure that the data being sent and all received, all these are really properly filtered. And if you're doing entirely on-premise, if you're doing totally isolated as a network on a hardware level, then it's a bit more secure, but you also have to make sure that the LLM is still receiving the right kind of data so that it can give a useful context and the replies to the users. But the problem comes when there are a lot of supply chain vulnerabilities, right? Because a lot of LLM libraries that are being used could be compromised as well. And these days, a lot of development teams are using AI to do the vibe coding, and a lot of the libraries used, sometimes some of the developers might not check properly and it might contain compromised data. So it's actually very important to have proper DevSecOps operations so that you do the proper testing, do the proper CI/CD, and all the securities are being tested, even if you are coding using AI. This will actually catch if there's any potential viruses. And it requires much more resources and high maintenance, which is why sometimes on the security side, not much effort is being put in. It requires more sophisticated network architecture to make sure that the protection of the organization network critical systems are in place. And because these kind of on-premise systems will handle much more sensitive data by design, so there's also a chance that these systems, when exposed, will reveal much more sensitive information and will be a much more trouble. So you need to have proper hardening and network design to make sure that everything is in place. There's also a potential for users to gain privileged access to the server via prompt injections. So maybe you do the proper network segregations and the users can only access certain part of the data, but if the LLM itself that you're using, the on-premise LLM that you're using, is not really secure, the users can actually have privileged access and they can somehow access the core database where all the sensitive data are sitting in. And there's a way to do lateral movement into the network from a compromised deployments, just like any other network devices, right? So any device that is not really properly secure, be it LM server, a PC, or anything, it can be a entry point for hackers to do lateral movement to move into other machines in the same network. So how to protect, right? So practicing some level of application security checks, as I mentioned just now. As part of the DevSecOps, you need to do the static application security testing, dynamic, interactive, as well as SEA supply chain. You need to be careful of that as well. SEA is software composition analysis, basically trying to find out what kind of libraries are being used, what are the versions, whether they are outdated, and it can actually generate SBOM. So this is actually a good practice. There's also hardening of the systems involved, right? So you need to make sure that all the systems that have services that, like for example, if there are any services that are not being used, it should be disabled, and everything must be hardened accordingly based on the international standards. And you need to design the network properly with the security in mind. And you need to know clearly which data are being accessed, sent out, and which are the potential entry points for the cyber criminals, so that you can actually know which part that you need to protect the most and which part you need to reinforce with more security. And when you're deploying air-gapped networks, it gets trickier because the standard methods and standard measures like the network data diodes, it does not work because of the unidirectional nature. So LLMs actually need bidirectional by nature, because users need to send some prompts and system need to come back with some replies. So it's more interactive. Whereas data diodes traditionally used for network segmentations are unidirectional in nature, because the use case mainly is to send data from one side of the network to the other side without actually physically connecting them with the network cable. So the use case is not really directly suitable for LLMs, which requires more advanced cross-domain tools like protocol breakers. Right? So what are protocol breakers? These are cross-domain solutions like data diodes. It actually connects two sides of the entirely separated networks, and it still allows you to transfer data across the two sides. And it can support both unidirectional and bidirectional use cases. It can maintain the same level of security as the data diodes due to the protocol breaking mechanisms. So what happens is, when you send a traffic, it stops the incoming protocol. It just takes the core, the necessary content, and it reinitiates a new outgoing protocol on the other side. So this actually allows for more granular configuration and filtering. So whatever data that you have in between, you can make sure that, for example, you don't really need any NRIC data or any sensitive information to be sent out, like credit card information, email addresses. You can have all sorts of filters to actually filter out all these contents before reinitiating and putting the data on a new protocol on the other side. So as an example, it could be like an HTTPS kind of use case, right? So when a client sends let's say a post request to the HTTP server, what the protocol breaker does is that on the upstream side, it actually has a HTTP server. It will accept the incoming protocol. It will accept the post protocol. It will interpret what's inside the payloads and the headers and all these. It will just take the core components without any hidden stuff that could be damaging. It will do also all these kind of filterings. And on the other end, it actually initiates a new post request to the destination server. So it's basically like a security guard in between, looking through everything, and everything okay already, then it will just send to the other side. So this is a very, very strict kind of security mechanism. This is a quick diagram to illustrate. So you have the two different security zones, and there is a protocol breaker in between. It can support TCP, UDP, FTP, FTPS, all sorts of protocols, right? Syslog, NTP, MySQL, HTTP. So basically, this device acts as kind of like a broker, right, in between, that actually does all sorts of security filtering, while making sure that the two security domains, the two networks, are physically separated. So as a bonus, I want to share one more innovation that I have come across before, which is called invisible organizations, right? So under the threat modeling frameworks like, for example, Lockheed Martin cyber kill chain, or like MITRE ATT&CK frameworks, the crucial first step for a cyber attack is reconnaissance. So basically, you need to discover, you need to do recon on the network, the servers that you want to attack. Only then you can actually know what to attack. So hackers need to do reconnaissance in order to understand where to start attacking. And it usually involves scanning for open ports and IPs by tools like Mmap. So what if there are no ports open at all in your organization, right? So when attackers do the scanning, they are trying to scan for open IP with open ports, which ports are accessible, what kind of services are running. But if there's no ports available, there's nothing for them to see, and there's nothing for them to attack. This is mainly the essence of the invisible organization technology. So there's no attack entry point, there's no lateral movement, there's no DDoS or man in the middle possible. One of the use cases that we use in the maritime industry is called invisible ship, right? So what happens is, imagine you have a ship sailing in the sea. We're not saying that we would just magically make the ship disappear. That would be a big trouble, right? Ships usually use satellite internet to actually get connected to the shore and all the different systems that it needs to access to. And it needs to report its locations via things like AIS. So we're not saying that we're going to turn off the AIS so that the ship doesn't appear on the radar. That would be illegal. What we mean is the ship has a lot of system components that actually is exposed to the internet as well. The crew LAN, the captain's PC, some of the systems actually has the access or somewhat of the backdoors for the manufacturers to remote in and support the ship when in the middle of the sea, right? So all these have TCP ports open that actually allows people from internet to come in. Of course, it's supposed to be for the authorized users, but there's always the chance of being abused, right? So when hackers try to scan the network, scan the IPs, it could come across the ship's IPs, and then if it's exposed, it could actually enter the ship's critical systems via internet. So when they do the scanning, they can find the IP and they can come in. So what if we close all these TCP ports? There's no open port, no incoming port open at all. There's no way for the hackers to find this ship at all from the internet. The scenario will be impossible. There's nothing that he can find, right? So that's a very interesting use case. And on a more enterprise corporate side of things, another use case is an SFTP server, right? So the standard way that the SFTP servers communicate is there's an SFTP server, maybe it's running on the port 22, and the user will connect to the IP of the SFTP server using the port 22. So then there's two-way communications, right? So the invisible way is that, for example, the SFTP server, it's only open to the local port, and there's a daemon software that actually has only the outgoing port open. So the daemon software will actually act as an intermediary to try to connect the SFTP server via the outgoing port to a rendezvous point. So there's like a couple of rendezvous ports that actually sits all around the world. And the users, when they want to connect to the particular SFTP server, it will has the particular name, same as how you will have an IP address. Now in this case, it's not an IP address, it's a name. And you will connect to it, and it will do all the necessary checks to make sure that this is an authorized user, and then it will actually connect. So basically the rendezvous point will be the broker that actually connects the SFTP server and the user. And both sides, they are only opening outgoing ports because they are just only initiating out the instructions. So the SFTP server initiates the connection, user initiate a connection, they get connected in between, and the user can access the SFTP server without any incoming ports open. So this is a very, very interesting technology, and there are a lot of use cases in many, many other areas. So as a summary, file-based malware, there's content disarm reconstruction, network-based traffic sanitization, you can use protocol breaker, and to eliminate any entry points, there's technologies like invisible organizations. With that, I'd like to conclude my talk, and thank you for listening. This is my detail. If you want to discuss more about any particular topic, or if you are curious, or if you are wondering how is that possible, just hit me up and we can have a chat. Thank you so much.